Hi viewers, so far we have discussed the various components of multimedia such as text, video, animations and sound. Now we move forward and start discussing the topics like how to make multimedia, the multimedia skills, planning and costing, internet and multimedia. In this lecture, you will be introduced to the workshop where multimedia is made, guidance and suggestions for getting started, and you'll learn about planning a project. Most multimedia and web projects must be undertaken in stages. Some stages should be completed before other stages begin, and some stages may be skipped or combined. Here are the basic stages in a multimedia project through which it has to pass: planning and costing, designing and producing, testing and delivering. You need hardware, software, and good ideas to make multimedia. To make good multimedia, you need talent and skill. You also need to stay organized. Multimedia development of any scale greater than the most basic level is inherently a team effort. Before beginning a multimedia project, you must first develop a sense of its scope and content. Let the project take shape in your head as you think through the various methods available to get your message across to your viewers. The most precious asset you can bring to the multimedia workshop is your creativity. It's what separates run of the mill multimedia from compelling, engaging, and award winning products. You have a lot of room for creative risk taking because the rules for what works and what doesn't work are still being empirically discovered, and there are few known formulas for multimedia success. Indeed, companies that produce a terrific multimedia title are usually rewarded in the marketplace, but their success can be fleeting. This is because competitors often reverse engineer the product and then produce duplicate using similar approaches and techniques. Good website ideas and programming are easily cloned. The evolution of multimedia is evident when you look at some of the first multimedia projects done on computers and compare them to today's titles. Taking inspiration from earlier experiments, developers modify and add their own creative touches for designing their own unique multimedia projects. It is very difficult to learn creativity. Some people might say it is impossible and that you have to be born with it. But like traditional artists who work in paint, marble, or bronze, the better you know your medium, the better able you are to express your creativity. In the case of multimedia, this means you need to know your hardware and software first. Hardware. This discussion will help you to understand the two most significant platforms for producing and developing multimedia projects: the Apple Macintosh operating system and the Microsoft Windows operating system, found running on most Intel based PCs. These computers, with their graphical user interfaces and huge installed base of many millions of users throughout the world, are the most commonly used platforms for the development and delivery of today's multimedia. Certainly, detailed and animated multimedia is also created on specialized workstations from Silicon Graphics, Sun Microsystems, and even on mainframes. But the Macintosh and the Windows PC offer a compelling combination of affordability, software availability, and worldwide obtainability. Regardless of the delivery vehicle for your multimedia, which could be a computer, a PlayStation game box, or as bits moving down the data highway, most multimedia will probably be made on a Macintosh or on a PC. The basic principles for creating and editing multimedia elements are same for all platforms. A graphic image is still a graphic image, and a digitized sound is still a digitized sound, regardless of the methods or tools used to make and display it or play it back. Indeed, many software tools readily convert picture, sound, and other multimedia files from Macintosh to Windows format and vice versa using known file formats or even binary compatible files that require no conversion at all. While there is a lot of talk about platform independent delivery of multimedia on the internet, with every new version of a browser, there are still annoying failures on both platforms. These failures in cross platform compatibility can consume great amounts of time as you prepare for delivery by testing and developing tweaks so your project performs properly in various target environments. Selection of the proper platform for delivering your multimedia project may be based on your personal preference of computer, your budget constraints, project delivery requirements, and the type of material and content in the project. Many developers believe that multimedia project development is smoother and easier on the Macintosh than in Windows, even though projects destined to run in Windows must then be ported and tested across platforms. Windows versus Macintosh. A Windows computer is not a computer in itself, but rather a collection of parts that are tied together by the requirements of the Windows operating system. These components, like power supplies, processors, hard disks, video and audio components, monitors, etc., are assembled and branded by Dell, HP, Sony, and others into computers that run Windows. If you are handy with a screwdriver and can read instructions, you can even order the parts and assemble your own computer to run Windows at a considerable cost savings. Unlike Microsoft, primarily a software company, Apple is a hardware manufacturing company that developed its own proprietary software to run the hardware. In 2006, Apple adopted Intel's processor architecture, an engineering decision that allows Macintosh to run natively with Windows. All recent models of Macintosh come with the latest Mac operating system, and using Boot Camp or parallel software, Macintosh can also run the Windows operating system. Connections. The equipment required for developing your multimedia project will depend on the content of the project as well as its design. You will certainly need as fast as computers as you can lay your hands on, with lots of RAM and disk storage space. If you can find content such as sound effects, music, graphic art, clip animations, and video to use in your project, you may not need extra tools for making your own content. Typically, however, multimedia developers have separate equipment for digitizing sound from tapes or microphones, for scanning photographs or other printed matter, and for making digital still or movies. Table here shows various device connection methodologies and their data transfer rates. The small computer system interface, pronounced SCSI, adds peripheral equipment such as disk drives, scanners, CD-ROM players, and other peripheral devices that conform to SCSI standard. SCSI connections may connect internal devices such as hard drives that are inside the cabinet of your computer and use the computer's power supply. External devices which are outside the cabinet use their own power supply and are plugged into the computer by a cable. The hardware and the drivers for SCSI have improved over the years to provide faster data transfer across wider buses. Unlike the less expensive IDE scheme, a SCSI controller does not demand CPU time, and because it can support many devices, it is often preferred for real-time video editing, network servers, and situations in which writing simultaneously to two or more disks is required. Integrated drive electronics or IDE connections, also known as Advanced Technology Attachment, that is ATA connections, are typically only internal and they connect hard disks, CD-ROM drives, and other peripheral mounted inside the PC. With IDE controllers, you can install a combination of hard disks, CD-ROM drives, or other devices in your PC. The circuitry for IDE is typically much less expensive than for SCSI, but comes with some limitations. For example, IDE requires time from the main processor chip, so only one drive in a master/slave pair can be active at once. USB, a consortium of industry players including Compaq, Digital Equipment, IBM, Intel, Microsoft, NEC, and Northern Telecom, was formed in 1995 to promote a universal serial bus standard for connecting devices to a computer. These devices are automatically recognized and installed without users needing to install special cards or turn the computer off and on when making the connections, allowing hot swapping. USB technology has improved in performance since its introduction and has become the connection method of choice for many peripheral devices, from cameras to keyboards to scanners and printers. USB uses a single cable to connect as many as 127 USB peripherals to a single personal computer. Another data transfer standard introduced by Apple in the late 1980s, called FireWire, has become an industry standard supporting high bandwidth serial data transfer, particularly for digital video and mass storage. Like USB, the standard supports hot swapping and plug and play, but it is faster, and while USB devices can only be attached to one computer at a time, FireWire can connect multiple computers and peripheral devices. Both the Mac OS and Windows offer FireWire support. Because the standard has been endorsed by the Electronic Industries Association and the Advanced Television System Committee, it has become a common method for connecting and interconnecting professional digital video, from cameras to recorders and edit suites. Sony calls this standard iLink. FireWire has replaced parallel SCSI in many applications because it's cheaper and because it has a simple adaptive cabling system. Input devices. A great variety of input devices such as the familiar keyboard, handy mouse, touch screens, and voice recognition setups can be used for the development and delivery of a multimedia project. If you are designing your project for a public kiosk, use a touch screen. If your project is for a lecturing professor who likes to wander about the classroom, use a remote handheld mouse. If you create a great deal of original computer rendered art, consider a pressure sensitive stylus and a drawing tablet. Scanners enable you to use optical character recognition software such as OmniPage from ScanSoft. With OCR software and a scanner, you can convert paper documents into a word processing document on your computer without retyping. Barcode readers are probably the most familiar optical character recognition devices in use today, which we can spot at markets, shops, and other point of purchase locations. Using photocells and laser beams, barcode readers recognize the numeric characters of the universal product code that are printed in a pattern of parallel black bars on merchandise labels. For hands-free interaction with your project, try voice recognition systems. Most voice recognition systems currently available can trigger common menu events such as save, open, quit, and print, and you can teach the system to recognize other commands that are more specific to your application. Systems available for the Macintosh and Windows environments typically must be taught to recognize individual voices and then can be programmed with the appropriate responses to the recognized word or phrases. Dragons, naturally speaking, takes dictation, translates text to speech, and does command to click, a serious aid for people unable to use their hands. The quality of your audio recordings is greatly affected by the caliber of your microphone and cables. A unidirectional microphone helps filter out external noise, and good cables help reduce noise emitted from surrounding electronic equipment. Digital cameras use the same CCD technology as video cameras described in earlier lectures. They capture still images of a given number of pixels, and the image are stored in the camera's memory to be uploaded later to a computer. The resolution of a digital camera is determined by the number of pixels on the CCD chip, and the higher the megapixel rating, the higher the resolution of the camera. Images are uploaded from the camera's memory using a serial, parallel, or USB cable, or alternatively, the camera's memory card is inserted into a reader connected to the computer. Output devices, presentation of the audio and visual components of your multimedia project requires hardware that may or may not be included with the computer itself, such as speakers, amplifiers, projectors, and motion video devices. One can test the benefits of good output hardware by feeding the audio output of your computer into an external amplifier system. Suddenly you feel that the bass become deeper and richer, and even music sampled at low quality has become acceptable. Often the speakers you use during a project's development will not be adequate for its presentation. Speakers with built-in amplifiers or attached to an external amplifier are important when your project will be presented to a large audience or in a noisy setting. The monitor you need for development of multimedia project depends on the type of multimedia application you are creating, as well as what computer you are using. A wide variety of monitors are available for both Macintosh and PCs. Serious multimedia developers will often attach more than one monitor to their computers because they can work with several open windows at a time. Graphic print designers often use special color correction hardware to ensure that what they see on screen matches precisely with what will be printed. Hard copy printed output has also entered the multimedia scene. From storyboards to presentations to production marketing material, printouts are an important part of the multimedia development environment. Software. Multimedia software tells the hardware what to do. The basic tool set for building multimedia projects contain one or more authoring systems and various editing applications for text, images, sounds, and motion video. Multimedia authoring tools provide the important framework you need for organizing and editing the elements of your multimedia project, including graphics, sounds, animations, and video clips. Authoring tools are used for designing interactivity and the user interface, for presenting your project on screen, and for assembling diverse multimedia elements into a single cohesive product. Authoring software provides an integrated environment for binding together the content and functions of your project and typically includes everything you need to create, edit, and import specific types of data. They also assemble raw data into a playback sequence or cue sheet and provide a structured method or language for responding to user input. Each multimedia project you undertake will have its own underlying structure and purpose and will require different features and functions. E-learning modules such as those seen on PDAs, MP3 players, and internet may include web-based teaching materials, multimedia CD-ROMs, discussion boards, simulations, games, and learning management software. This is also referred to as distance learning or blended learning, where online learning is mixed with face-to-face learning. Authoring tools. The various multimedia authoring tools can be categorized into three groups based on the method used for sequencing or organizing multimedia events and elements. Card or page based tools, icon based tools, and time based tools. Card based or page based tools are authoring systems wherein the elements are organized as pages of a book or stacks of cards. Thousands of pages or cards may be available in the book or stack. These tools are best used when the bulk of your content consists of elements that can be viewed individually, letting the authoring system link these pages or cards into organized sequences. You can jump on command to any page you wish in the structured navigation pattern. Page-based authoring systems such as LiveCode from Runtime Revolution and Toolbook contains media objects such as buttons, text fields, graphic objects, backgrounds, pages, and even the project itself. Icon and object-based authoring tools. Icon or object-based event-driven tools are authoring systems wherein multimedia elements and interaction cues are organized as objects in a structural framework or process. Icon-based event-driven tools simplify the organization of your project and typically display flow diagrams of activities along branching paths. In complicated navigational structures, this charting is particularly useful during development. Icon-based tools provide a visual programming approach to organizing and presenting multimedia. With icon-based authoring tools, non-technical multimedia authors can build sophisticated applications without scripting. In Authorware from Adobe, by placing icons on a flow line, you can quickly sequence events and activities, including decisions and user interactions. These tools are useful for storyboarding as you can change sequences and add options and restructure interactions by simply dragging and dropping icons. Time-based authoring tools. Time-based tools are authoring systems wherein elements and events are organized along a timeline with resolutions as high as 1/30th of a second. Time-based tools are best to use when you have a message with a beginning and an end. Sequentially organized graphic frames are played back at a speed that you can set. Other elements are triggered at a given time or location in the sequence of events. This brings us to the end of our discussion, and in this lecture you were introduced to the workshop where multimedia is made. We talked about guidance and suggestions for getting started, and you learned about planning a project. Most multimedia and web projects must be undertaken in stages. Some stages should be completed before other stages begin, and some stages may be skipped or combined. So friends, that is it for today. See you in the next lecture. Thank you very much.